we're going to start 1.11, and we're not going to finish it today, so that's fine. So we started with doing that division problem, long division, and the process of doing that when we have rational functions is because it gives us a slant asymptote. This graph right here has a slant asymptote. You see the slanted dotted line?
Yes, ma'am.
Yeah, so when we have a vertical asymptote, a vertical line, the equation of the line is like x equals a number. The equation of a horizontal line is y equals a number. But a slanted line needs a full y equals mx plus b. So, because that's the equation of a non-vertical or horizontal line. And so doing the long division, or doing division with rational functions will give you that equation. So we're going to do that. So if the degree of the numerator is exactly 1 greater than the denominator degree, that means there is a slant asymptote.
So like the remainder fraction of this.
If you have a rational function, if it's an x cubed on top and an x squared on bottom, it has a slant asymptote. Because the degree on top is exactly 1 more than the bottom. If you have an x to the 4th over x squared, no slant. It's only when it's exactly 1. If you have x to the 7th over x to the 6th, slant asymptote. You may be asked a simple question like, you might have a rational function on the AP exam and it asks like about the features. It might say it has 1 slant asymptote, 1 whole, 2 vertical asymptotes or something. It could be a simple question where it's just in there and you just have to know if it does or not, which is easy. Is the degree on top 1 more than the bottom? But if it actually asks for the full equation, that's when you have to do division. Now in Algebra 2, I taught you synthetic division. That's where you have, and we're not even actually going to work this out, but that's when you like had the box in the top and you wrote the numbers out. Do you remember doing something like that?
No.
Maybe? No. Well, we did. But that only works in certain situations. So we're not even going to practice that because we're just going to do the long division and then you're just going to know how to do it and it'll be okay. You should always use long division. So here is how we do it. If you look right here, divide, we divided first. Multiply, over here we multiplied first. Subtract and bring down, subtract and bring down. It's the same steps, just slightly more complicated because it's not just numbers. So first we're going to write our problem out. What's in the numerator that goes under the, somebody called it a tree?
Oh, I know.
Is that what this little thingy? I don't know what it's called.
I've never used it.
It's called the what? The doghouse. Okay, it goes under the, that's what I was taught in elementary school. I do remember that. Okay, well, let's, unless you're going to share, put it back. Alright, so here's what we do. Step 1, divide the first term of the numerator, which is what we've got under the doghouse, by the first term in the denominator. Think about it when we're looking at horizontal asymptotes, we only care about the leading term. So this first step, it's only the leading terms. So you're going to divide. I'm going to go over here. X squared divided by x.
Which is 2 squared.
X squared divided by x is x. And so that goes on the top. Just like we did here. We did the 15 divided by 4. Well, that was 3 and then you plus a little bit. Okay? Because it didn't go perfectly. This x squared doesn't go, we can't divide this perfectly, but we get close.
Oh yeah, because 2x is the same as 2x.
Yep. So that's the dividing. Then we're going to multiply. Now when we multiply, we have to take this x, we do have to multiply it by everything. So x times x is x squared. X times negative 2.
Where were you getting negative 2 at?
Because this is a minus 2.
Okay.
Negative 2x. Okay, so that's my multiplication. So we first did the division, then we multiplied. What's my next step? Subtract. So I have to subtract this whole thing. So I'm going to put it in parentheses because we subtract it all. I'm going to do x squared minus x squared. 0. Those cancel. X squared divided by x squared is 1. X squared minus x squared cancels. That's what should happen. Your first one should always cancel. And then, well, what's 2x minus negative 2x? 4x. Okay, so we subtracted and then bring down. And then we repeat the process. So what's my first thing that I'm looking at? 4x, and I'm dividing that by the first term over here, x, which is 4. Now, we can actually stop here. The equation for a slant asymptote is whatever, when we divide, we don't include the remainder. So anything we do after this, once we have x plus 4 or 2x minus 5 or whatever, you have all you need for the slant asymptote. You don't have to finish dividing it all the way. Everything I did would just give me a remainder. So you can stop and you can say we have a slant asymptote at y equals x plus 4.
So every time we get to the first number, whether it be plus or minus, that's where we stop?
It's whenever you get like a full, like mx plus b left in the above. Like when your answer is it might be 2x minus 1. It might be x plus 7. It might be negative x plus 3. But enough where it's a y equals mx plus b.
Oh, okay. So
And it'll be like the same number of steps every time.
Gotcha.
All right. So let's do another one. Alright, so I'm going to write the steps. Divide leading terms. And then we multiply. And then we subtract. And I don't like my color options. And then we bring down. So those are the steps that we're going to follow. So my first step is to divide the leading terms. So I'm going to take the 5x squared and divide it by x. If you want to write that over here, you can. You don't have to. Basically, one of the x's is going to cancel, leaving you with 5x. And then my next step is to multiply. So I take this 5x and I multiply it by all of the terms on the outside. What's 5x times x? 5x squared. 5x times 6? 30x. Okay. So next step is to subtract. if we do 5x squared minus 5x squared, that does cancel. And then it's 28 minus 30, which is going to be what? Negative 2x. And then bring down the minus 8. And we go back to the beginning. So if I take negative 2x divided by x, that is what? Negative 2, because like the x's cancel. So we have a minus 2, and there is no need to keep going. You could finish dividing it, but when it's only asking for the slant asymptote, you're done. So we have a slant asymptote at y equals 5x minus 2. Yes.
Where would you get the x at to divide negative 2x by x?
So every time we're dividing by the leading term out here. So I started with this leading term divided by x. Now I'm doing this leading term divided by x. And if I kept going, I would take the next leading term divided by x. So let's do another one. This one's a little different because it's not just x, it's 2x.
So we take that leading term divided by that leading term, which would give us x, right?
Alright, so set it up. We take the leading term, which is 2x squared, and we're going to divide it by the leading term on the outside. So if we write 2x squared, I'm dividing that by 2x. So the 2's cancel, and then one of the x's cancel, leaving you with x. Then you multiply. What is x times 2x? X 2x squared, because you have an x times x. And then x times negative 9, negative 9x. So that's my multiply step. And then I subtract 2x squared minus 2x squared cancels. Negative 3x minus negative 9x is 6x, positive 6x. Bring down the minus 21, even though we're not actually going to do anything with it because I know I'm going to stop at the next step, but that's what we do. So then we're ready to go back. This is 6x is my new leading term that I'm still going to divide by this one out here, 2x. 6x divided by 2x. Those cancel, just leaving us with positive 3. So I have a slant at y equals x. So tomorrow we'll do these last two, and then you'll just do some practice with them.